So now let's talk about AWS Lambda. And first, its integration. So there are some main integrations you need to know, such as API Gateway to invoke Lambda from a REST API, Kinesis to read data from a stream, DynamoDB to read data from a changelog stream from DynamoDB, S3 to react to new objects being created in Amazon S3, for example, Internet of Things, Event Bridge as pretty much a rule output from any kind of event in Event Bridge, CloudWatch logs, we have SNS to react to notifications, Cognito to do some pre and post authentication hooks with Lambda, and SQS to read data from a queue. So here's an example, a very famous one, which is the serverless thumbnail creation. So we have a new image in Amazon S3, which is going to trigger a Lambda function to create a thumbnail. It's going to push the new thumbnail in Amazon S3 and maybe push the metadata of this thumbnail in DynamoDB that contains the image name, image size, creation date, and so on. Another very, very common architecture with Lambda is to use Event Bridge to create a time-based trigger to trigger a Lambda function every 1 hour to perform a task, effectively giving you a serverless cron job. So Lambda supports a lot of runtimes, such as Node.js, Python, Java, C#, Golang, Ruby, the custom runtime APIs to enable you to support even more languages, such as Rust, for example. Also has support for container images that are very specific. They need to be implemented with the Lambda runtime API. So if you want to run a container image on Lambda, you can. But if it's an arbitrary image, then you want to use ECS and Fargate instead. So Lambda will come up in the exam, especially as difference, for example, versus batch or versus ECS and other things like this. And so knowing the limits of Lambda really helps you understand whether or not Lambda is a good choice. So Lambda has up to 10 gigabytes of RAM, and the CPU is linked to RAM. So 2 vCPUs will be allocated at about 1800 megabytes of RAM, and 6 vCPUs will be allocated at around 10 gigabytes of RAM. Timeout is up to 15 minutes. So if you have long executions, for example, 1 hour, Lambda is not a good use case. And the temporary storage is 10 gigabytes. Here are the deployment packages limits: 50 megabytes zipped, 250 megabytes unzipped, including layers. You can get up to 1000 concurrent executions, although that soft limit can be increased. And the max image size for a container is 10 gigabytes, as well as the invocation payload, 6 megabytes when synchronous and 256 kilobytes when asynchronous. So talking about concurrency, Lambda has up to 1000 concurrent executions. So that means that you can go from having 2 Lambda executions concurrently to 1000. And you can set a reserved concurrency at the function level, which is going to make sure that there is a limit, but also a reserved capacity for a specific function. Now, each invocation over the concurrency limit is going to trigger a throttle. And so when you're throttling, you can retry your request. And if you get too much throttling, then you can request a quota increase in the AWS service quotas service. Now, we have a Lambda concurrency issue if we don't reserve concurrency. So say we have an ALB with Lambda, we have API Gateway with Lambda, and we have also users using the SDK or the CLI to invoke Lambda functions. So this is fine until someday your application on the ALB gets very, very popular and you have many more users, and all of a sudden you have up to 1000 concurrent executions of Lambda. And the few users on the API Gateway are going to be throttled, and the users of the SDK or CLI also will be throttled. So if you don't reserve concurrency, this can happen. And so therefore, you would reserve concurrency for the API Gateway and reserve concurrency for the SDK, and that you would not run into this issue because there will be a minimum number of Lambda functions that can run for your API Gateway and so on. You can also deploy Lambda functions with code deploy. So code deploy will help you do traffic shift between 2 Lambda aliases or versions. And so this feature is integrated directly within the SAM framework. So say you have a prod alias pointing to the v1 and the v2 function. Using code deploy, you can shift gradually the traffic from v1 to v2 by having first 100% on v1 and 0% on v2, and then slowly going 80-20 and so on. So for this, code deploy will make that proportion vary over time. So you have different strategies. You have the linear to grow traffic every n number of minutes until 100%. So it's linear growth. So you have, for example, 10% every 3 minutes or 10% every 10 minutes. And you can try canary as well to try a small amount of traffic for, say, 5 minutes, so 10% for 5 minutes. And then if everything is stable and no rollback happens, then switch all the traffic over. So it's a bit quicker, and you just test a small subset. That's why it's called canary. So you get canary 10% 5 minutes, or canary 10% 30 minutes, and so on. And if you don't want to transition from V1 to V2, you can do all at once to get immediate traffic shift between your two Lambda versions. You can also run pre and post traffic hooks to check the health of your Lambda function so that you don't move over all the traffic to the new one after a canary if you don't validate some kind of health checks and post traffic hooks. Now, regarding monitoring, so CloudWatch is going to be good because you're going to get all your execution logs in CloudWatch logs, and also CloudWatch metrics. You're going to get all information around successful invocations, error rates, latency, timeouts, and so on. And so for this, you need to make sure that Lambda has an execution role that allows access to CloudWatch logs, for example. Now for X-ray, it's possible to trace Lambda functions invocations with X-ray. And so for this, you just enable it in the Lambda configuration to run the X-ray daemon for you. And then in your code, you would add the tracing mechanism directly using the AWS SDK. For this, again, you need to make sure that your Lambda function has correct access to X-ray. So that's it for the first part of Lambda. I hope you liked it, and I will see you in the next lecture.